many of the stories you'll hear today would not have been possible without amazing developments in medicine. And that got us thinking about advancements that seem out of this world. So to break it all down for us, we've got our very own Dr. Coley with us. Dr. Coley, hello.
I want a little clap.
Yes.
I felt you standing over there in the beginning. And
it's an awkward space when you're alone over there. Yeah,
you nailed it.
Let's jump right in.
Should I take a little bow?
There you go. Do a little curtsy.
Oh, good one.
Never mind. All right, let's get into this. 3D printing. Okay. For your organs. It blows my mind. I can't believe this is a real thing.
How is that possible?
I want to ask you about something that, come on. 3D printing has been used by doctors for years to help them practice, but now we're getting to a point where actual organs can be printed with organic tissue. I don't even know how that works. How close are we to actually doing this?
Well, we aren't just close, we're actually doing it. So there are patients in clinical trials who are getting organs. Now, these are the simple organs we're talking about. Skin cells, cartilage, bladder, because these organs have a simple geometry and architecture, usually only one type of cell or a few types of cells. And think about it like those old inkjet printers. You remember those?
Yeah.
Yeah.
Is it really kind of similar?
It's exactly the same. It's an inkjet printer. Instead of the ink being real ink, it's actually tissue. It's cells. So you just put it's called bioink. You put it in there and it prints the organ on a scaffold.
Can you use like your own cells so it's less rejection for the organ?
That's exactly what we do. So we take tissue cells from the person that's getting it. So in the case of this woman who got her ear was malformed as part of a congenital condition. They actually took her cells, printed her ear, put it on, and it's simple. Now the challenge here comes with the blood vessels, right? And the blood supply to the organ. That's more difficult to put in there because you're talking about a network of blood vessels. So the more complex organs we're still a ways from. Jeff?
So things like wound therapy, with people who they don't close up. I had to go to a wound therapy place.
Your hot tub accident.
Yeah, well, yeah, kind of. Yeah. But yeah, that makes a lot of sense.
So
to cover.
Skin grafting, burn victims, you can print a piece of their skin, and the skin is complicated too. It has hair cells and those other types of cells on it as well. But imagine what that could do for patients. Imagine what that could do for cosmetic surgery. Imagine what that could do for beauty products. Currently, we test them on animals, right? We could go completely cruelty-free.
Love this.
Just do it on like tissue in the lab and not have to use animal testing to get our cosmetics approved.
And one day they can print food and we can end hunger. And that's what I'm hoping for. I'm not kidding. It is in the works.
Where do you get the...
It's made of a peanut butter synthetic that comes out and it can feed in packets thousands and millions of people that it's flat and they ship it out.
Thousands and millions?
Yeah, both of them. One of the things I've been curious about is how doctors can do surgery with robots. Is this safe? What's going on?
Yeah, the first time I saw it in medical school kind of freaked me out a little bit because we were many rooms away from the patient. There was just a robot in the operating room with the patient. We were sitting like in a control room and the robot was doing surgery, but we were controlling the robot.
Back when you were in medical school?
Wow. Yeah, and so the idea here is that robot can get into places that you can't, right? So there's improved dexterity, improved accuracy, because the robot is a little bit more sort of delicate in its surgery, and you can see better. But if you think about driving a car, it took us years to learn how to drive a car. So learning how to drive a robot as a medical professional, there's a steep learning curve. So the safety is highly dependent on the people who are driving the robot. And then what if the robot gets you in trouble, right?
Can it malfunction?
Absolutely.
Oh, wow.
And it has. In fact, I've seen a couple cases where it does malfunction, cuts into the wrong thing or doesn't turn fast enough.
And then who do you...
Well, then the surgeon has to come in. So with respect to safety, I think it's made surgery safer overall. It's actually great technology. I'm so excited about it. But I do think it has to be the right place and the right surgeon who is operating that robot.
Wow. Fascinating.
Wow.
Unbelievable. DBL Nation, you got to follow Dr. Coley on social media at Pyle Coley MD. Also, be sure to subscribe to her YouTube page. Plus, check out her podcast, Heart of Medicine, wherever you listen to your podcast. Thank you again, Dr. Coley. Appreciate you as always.